I would like to introduce Rich McCraw, the Vice President of Improving's Atlanta office. Over the course of his 18 years with Improving, Rich has extensive experience with creating enterprise application platforms. His experience covers everything from back-end database integration to API management and API security, and has proven invaluable to his clients. Rich has served demanding clients, AT&T, Disney, even Microsoft, and has proven he knows how to build and implement data platforms. And now to tell you if your data platform is up to snuff, take it away, Rich McCraw.
All right, slides are moving. We can actually get through this now. As Bud said, Rich McCraw, 18 years with Improving, VP out of our Atlanta office, and focus mostly on data solutions. This is part of our Tomorrow Technology Today webinar series. If you've been following along so far, we've had two so far. Devlin started with how technology is holding back business value at the beginning of month, followed by Andy talking about platform engineering. And kind of in the vein following up on how Devlin set the stage back at the beginning of the month. We want to talk about things where we make sure we're not just chasing trends with our technology choices. Why and when are we picking platforms? And how are we making sure we get value out of them rather than just chasing the latest buzzword or magazine article? And so with that in mind, what I want to talk about today is whether or not the modern data platform your organization's using is really modern, right? How much of this is actually bringing something new to the table, bringing something that you and your organization can leverage into the future and unlock more value with, and how much of it's just chasing buzz. And how can you look at the platform you have in place or the platform you're looking to implement and determine, are you really getting the things you need out of a modern data platform from it? Or is it really just another SKU, just like the last 20 or 30 years of data platforms? To do that, we're going to do a very quick dive into a brief history of data, just so we kind of talk about how we got here. And then we're going to dive into what makes a modern data platform modern. And we're going to talk through some different characteristics of a modern data platform. We'll finish up with a brief talk of kind of what parts of those are in the platform versus what parts are in how you use the platform. And hopefully that'll get us, at least in the next hour, with a better understanding of what we should be looking for and what we should be leveraging out of these platforms. So, as I said, I want to start with a very brief kind of history of data. And we're not going to go through a ton here, but just to give an idea of how data systems have grown over the history of IT. Right? Early on, we needed a way to store data and read it back, right? That's simple enough. Back from the earliest days of computing, right? And that's kind of how we came up with the database. It gave us a place to store a record and retrieve a record, right? As systems grew and became more interconnected, we got more data sources, more of our businesses moved into the digital age. How can we use those records with other data? How can we look at it in multiple ways? How can we get new insights on our data, right? So we began to build data warehouses, multidimensional models. We began to do things that were more than just storing and retrieving records, right? And then as we moved into the modern age, right, how much data could we store? We started being able to generate way more data than the older systems could either store, retrieve, or handle in an economical way. How do we process it as quickly as we generate it, right? And that's where we start getting to technologies like big data and the data lake and some of the things we'll talk about today. But even if we just think about kind of that simple, growth from how do we store and retrieve a single record to how do we store and retrieve all of the sensor data off of a network of IoT devices, there's a lot more complication that really gets added on top of this when we go to implement it. Well, maybe we want it to be in the cloud. We don't want to be tied into a specific vendor or platform. We also need to feed data science and analytics, AI and ML, right? there's a lot to this. This is no longer just a simple data retrieval platform, right? A modern data platform really spans a kind of variety of both functionality and use cases, from how we acquire data, how we persist it, how we visualize it, how we feed analytics. These things are truly ecosystems. We have to solve a lot of problems, right? No longer just data storage. The way we use it in our organization has changed as well, right? Rather than just being a system that supports operations, right? To becoming a system that may help us optimize operations, right? Or inform a decision, right? We're now becoming organizations that are truly data-driven, where the value and the insights we get out of the data define what and how the business may grow over the coming years. Where for some industries, for some businesses, the data itself and its insights become the value of the business. As we do that, the number of problems we have to solve continues to grow. Are we more interested in data volume or data velocity, right? How fast we're able to gain those insights, or over how much data we pull into those insights? What kinds of data and what variety of data do we need to look at, right? Are these simply purchasing records from a point of sale system? Are we talking about social media posts? Are we talking about, fully unstructured, video and mixed media, right? There's a great variety of problems we've got to solve with these platforms. So with that, as you can guess, the number of solutions needed to fill the space has changed. So if we look here, this is a venture capital firm, FirstMark, that does a yearly survey of kind of all of the solutions that are kind of, truly out there in the space and grabbing market share. So you see here in 2016, right, there's a lot of data solutions. None of us probably can name them all, right? But you can at least read what's on this chart. Well, 4 years later, got a lot bigger, right? 3 years later, that's pretty hard to read, right? At least we can identify maybe what some of the groupings are, right? But this space just continues to explode in complexity and variety of tools. And even from last year to this year, right? I challenge any of you to have better eyesight than I have and be able to read any of those logos, right? The space has become absolutely massive. So as we look through these tools, how do we determine what they're bringing to the table? How do we determine what's different, or what we're going to leverage, and why we need this wide variety of tools, and how to put together the right kind of ecosystem? So to that, the first question I want to talk about here today is simply, what is modern data, right? And in this case, I called it the Generative AI Edition because I went to ChatGPT and I said, give me a slide or an image of a slide for what is modern data. And that's what you see here, right? And I felt like it was quite representative of modern data. It's kind of vague. Depending on where you look, it may or may not make sense. Some of it may actually have words there, right? Some of it, cloud, right? Makes no sense at all. This is very similar to how people talk about modern data. It's this big umbrella under which we shove so many things that there's not always a coherent answer to what is modern data, what does it bring to the table, or how is it different. Moreover, if you go ask a different person, or in this case, a different generative AI model, exact same prompt, you're going to get an answer that's quite different, right? Nobody's going to be able to tell you what's modern data for every organization and every architect out there. Now, for people who actually can use AI in a better way than generating just kind of a image on a slideshow that made little sense, we do have 2 AI talks coming up. So I highly recommend those if you're interested in actual good ways to use AI rather than just generating a semi-readable slide image. But for modern data itself, perhaps we should answer the question by what problems does it solve? So what is modern data? Is it big data? Is it just because we have more? Is it the scale of the data and the types of questions we ask it? Is it because we can feed it into data science or how it provides analytics? Is it because it's in the cloud? Is it because it's just new and expensive, right? What is a modern data platform? We're going to spend the rest of the day talking not about those questions specifically, but instead by the characteristics of how it solves those problems and what makes it modern compared to other platforms. And so kind of regardless of what vendor you're going for, what you need to be able to see out of your modern data platform in order to know that it's going to both help you solve the problems of today, but also the way data ecosystems are going to evolve over the coming years. So as we do that, I think the first thing we want to talk about for a modern data system is simply structured versus unstructured data. Modern data deals with more kinds of data, right, than classical OLTP database systems. So since the beginning of computing, we've always had structured data. Right? This is data we know. We can store it in predefined structures. It's very easy to query. It's very regimented. We know the data types. We know how to determine if it's clean. We know how to use and manage these types of structured data systems and really always have. But we also, on the other end of the spectrum, have unstructured data. And this can be data for multiple formats. It can simply be raw, unprocessed data. We can perhaps search across this data, but we don't have a nicely defined model that all of this data is going to fit into, and that's going to fully define every aspect of it. But in reality, we probably don't live in either of these worlds, either the fully structured or unstructured world. What we really live in today is a semi-structured world. We have lots of data that's loosely organized, stored in a large variety of formats, normally has metadata attached to it that may describe parts of the data, but not in full consistency or full definition, and without a common definition, right, between a lot of these different sources. But this does let us provide both some degree of a model for query and some type of textual search, like we could do over unstructured data. What this does is it lets us start to solve problems, both against larger sets of data and in more iterative ways than we could in a fully structured or unstructured world. So what's that look like when we start talking about our modern data systems? Well, first off, why is it part of a modern data system, right? Unstructured data's always been around. We just didn't build systems around it. So what changed? Well, we developed better tools. We've simply gotten better at dealing with it. We have ways to make it a more palatable problem, right, for developers and engineers to solve. We can store it cheaply, right? 20 years ago, storage cost a lot more than it costs today. So the idea that I may be storing data that I may or may not use, right, is something that just has changed from an economic viability standpoint over the last several decades. And then finally, we just have a whole lot more of it. If you look at the growth of structured and unstructured data over the last 50 years, you can see that in the 90s, as digitization really took over the corporate world, we had about as much structured data as we did unstructured. But if you look in the modern day, we have many times more unstructured data than we do structured data. So if we really want to leverage this large amount of data that we can find out about our world and about our businesses, we can't just focus on that well-defined, easily organized set of data. We're just leaving too much on the table. We also have come to a point where we're looking at streaming data, right? And in this case, the data may not only be unstructured or semi-structured, but it's coming in real time, right? You can think of APIs, right? Things we would typically talk about as messaging. But in this case, right, we also talk about it in our data solutions and how our data solutions can handle this real-time streaming or event-driven world. Because we only have an hour today, I'm not going to be able to dive into this part very much. But we do have a talk specifically on real-time data systems coming up in another 2 weeks. So I certainly recommend anyone who wants to know more about streaming data or real-time data to make sure you register it and listen to Stephen at the end of the month. As we talk about that unstructured data, though, we have to talk about how we're going to store it, because we can't store it in those traditional OLTP database tables, those required fully structured data formats. So as part of what we do in a modern data platform, we've made a split from the way we used to see storage and compute of data. In the traditional database, right, we had a database server. And if we wanted failover, or we wanted to have a read-only copy, so reporting load could be separate from our transactional load, we added another server, right? And those servers had storage, those servers had compute, right? They used SQL Server or Oracle, or whatever our platform was. And if I needed them to be more powerful, I just got bigger boxes, right? And so whether or not I needed more CPU, right? I needed to solve bigger problems, or I needed to store more data, right? I just had to scale this up. And whether or not I was using a single server or a SAN, right? The idea is the same. The way I scaled was simply by getting bigger. Well, in the modern ecosystem, we instead have created a tier of data solutions that can store that semi-structured, structured, and unstructured data together. And we can talk about how we look at, scale, and store data as a completely different problem than how we process data. And instead, we can bring the different processors, right, or the different data workers to the data, instead of having to tightly couple the two and just make the box bigger. And that's what's going to unlock a lot of the rest of what we talk about when we talk about modern data. So really at the core of that becomes that storage, that storage that we're going to use across both different kinds and varieties of data, but also different data workers or data processors. Oftentimes, we just refer to this as a data lake or a lake house or a Delta Lake. This is a picture of an Azure data lake from Microsoft's Azure platform, right? You see it's got a data store at the bottom, right? And analytics is separate on top. But this isn't an Azure specific thing, right? This is really a concept that goes across almost all of the modern data platforms in one form or another, right? And the real core of it is the lake or the data lake is a place where all the data can go in either structured or semi-structured or unstructured form. And we can point our different problems and workloads to that data, right? We could do machine learning or analytics or reporting or data transformation, all against that data store, rather than having to put the data on every different type of system we may want to use it on. There are a lot of terms here that, for the most part, don't mean tremendously different things, right? People will talk about a data lake or a data warehouse or a data lake house or a Delta Lake. And there are small differences, right? The data warehouse normally is an organized, structured set of tables or models, right? The lake is actually the storage itself. A lake house is a mix of the two. So it is the storage with some modeling on top. Delta Lake's a specific format to make that easier to process in different ways. But for the point of what we're talking about today, right, the idea is kind of no matter which of these you've heard about or which of these you're using, what we've done is we've taken storage and we've solved it as its own problem.
Before we move on, We do have a question. What are some of the most common semi-structured systems?
So most data systems we use today can be semi-structured, right? In fact, semi-structured goes back, really back into the mainframe, right? So I mean, even in COBOL or old programming, right? We could do redefines. We could have fully undefined regions of data pages that really were um, only usable in very specific scenarios, right? Or where data could be put that perhaps would be later defined. In this case, right, as we move to data lakes, we have a lot easier ways to store it. We have a lot easier ways to search across it. But almost all modern, right, kind of non-OLTP data retrieval systems are going to support semi-structured in one form or another. Most things today, though, are going to use semi-structured in a way where there is at least some type of format or some type of pattern that semi-structured data is stored or structured in, right? So if we think about a JSON blob, right? JSON is a structured format. We know how to read or parse JSON. We know how to look at the hierarchy, but we may not know ahead of time what that structure is going to look like, what the values are, or how they relate to each other. So what we might do is store in a structured way some of the metadata or record data around that, and then have, for instance, in a case management system, a JSON blob of the case data itself. And that blob may be of wildly differing format, depending on the case type and the status, what different actions have been taken. So I may not know ahead of time, right, exactly how I could take that and, for instance, put it in a fully structured table. It's flexible, it's semi-structured. But because I'm using JSON, I do know how I can parse it and read it, right? And that lets me answer more questions about it later. That's different than, let's say, right, a stream of Facebook posts where the content is just free text and images, and then I might store as kind of fully unstructured data because I don't know how I'm going to parse that out, right? I might instead later use machine learning or AI to help categorize that data. So most times today, right, all of my data systems will let me query those elements as if they were structured, but simply in a more dynamic and real-time approach, right? If we talk about Snowflake or Databricks, right, or Microsoft Fabric, if I have those semi-structured stores or semi-structured data elements in my lakehouse, they kind of build into their processing engines ways to process and query into JSON blobs and XML blobs, et cetera. And so that's where most of that semi-structured data is going to come up today. Hopefully that answered your question. If not, feel free to ask a follow-up, or hopefully one of these next sections will also take us a little further down that path for you as we get into the tools that we use on this data. The other thing that's changed as we've decoupled these data platforms is storage is cheap, right? Or one of the reasons we've decoupled these data platforms, right? If we look over the last 50 years, computers have gotten more powerful and storage has gotten cheaper, right? And there's no indication that either of those curves are changing anytime soon. So with that, right, it seems to kind of, become obvious, the idea of storing more data or storing copies of data, right, really becomes more palatable, right? We're no longer in the days where we're trying to manage every kilobyte of storage as an absolute precious resource. This is especially true when we realize that data engineers are not becoming cheaper, right? If storage is becoming cheaper, engineers are not becoming more cheap, right? It can simply be more economical to say we're going to waste more storage, we're going to persist or store more copies of data at more stages of the transform, simply so that it is accessible and available, because it's going to save development time. It's going to help us with runtime. It's going to help us solve problems because the economic trade-off is just so small. But as you really look at most of the modern platforms, what you'll find is the answer is not simply, let's make as many copies of the data as we want, right? Because that is, while kind of easy to hand wave away storage costs, the volume of data we're storing, right, has continued to soar as well. So what's better than just having cheap storage, right, is having smarter storage, where perhaps we do store more data than we need, or we store it in more predefined formats so that we're able to use it as we need it. But most importantly, we want to store it in ways that are interoperable, because what hasn't changed and what won't change no matter how cheap storage gets is the complexities that come from having multiple copies of the same data and trying to keep it in sync, right? And trying to govern that and manage change across an organization. So instead, if we look at most of these platforms, these are examples from Microsoft Fabric, right? They have one link where we can take one copy of data, right? And we're able to store that or serve that one copy of the data to all different kinds of compute engines. So whether or not I'm using Synapse Data Engineering, or I'm building reports in Power BI, right? Or I'm feeding a real-time analytics stream, the same copy of the data sitting in that same interoperable store, right, can be used. So storage is cheap. I don't have to worry about how much I store, but I can still be much smarter about how many times or the complexity of my copies and my data footprint. In this case, for Fabric itself, we have a talk coming up in early November that'll give you a deep dive specifically on the Fabric platform. I'll mention Fabric a lot today. I'll also mention Snowflake and Databricks and AWS, because a lot of the things we talk about go across all these platforms. But as you want to dive into a specific platform in depth, we do have some of those talks coming up on the schedule as well. So like I said, it's not just Fabric, right, that takes this interoperable model, right? If we look at Snowflake, for instance, one lake can be supported both in Fabric and Snowflake. They both can read and write to it. Iceberg is a format that allows a lot of these platforms to utilize other platforms' data tiers, right? Or vice versa, to expose their data layers to compute engines that may not be part of their platform. On the left here, right, we have a Databricks architecture that shows an Iceberg-driven open data lake format. So again, kind of everything at that storage layer becomes interoperable between many of these platforms. There are other things that people have come up with as well in these platforms that make the storage unlock even more kind of new value or new patterns. So if we look at Snowflake, for instance, it uses micropartitions. These are immutable, very small table or pieces of tables, right, that get stored. And rather than updated, they simply have new copies or new partitions added to replace the old ones. And while that may seem like a very low-level implementation decision, what it enables are some really great new pieces of functionality across these platforms, right? In the case on the screen, I can create a clone of a table, make changes to it, but have only had to store the changes itself, right? It allows for much more compressed data footprints, but also in this case, significant easier identification of drift, of change. And one of the things that this enables in the Snowflake platform is time travel. The ability to go back and look at the state of your data before and after transactions over up to the last 90 days, depending on how you have the platform configured. It also enables data sharing, where I don't have to create full duplicates of the data to send both my internal or external partners. But where in this case, since the core data itself is actually being shared on a micro-partition level, updates can be seen by everyone in real time, right? I don't have to wait and reprocess and republish changes out to my different consumers. However, they're still able to enrich on top of the data, right, on their own storage without making additional copies on the platform, right? So some of these low-level storage decisions and the ability to treat storage separate from compute as its own set of problems really unlocks a lot of value in these modern platforms. Part of what that does for us, right, is storage. And then we talked about compute. Compute being not tightly coupled to those storage decisions. And what that's going to let us do is work with the data in more ways. Part of the reason we need to do this is simply the way we work with data and the types of people who work with data has changed over the years, right? We no longer live in a time where if I need a report, I can ask a data engineer to go build some type of abstract on a mainframe and hope that in a few weeks I can get something that's going to print out on a dot matrix printer, right? We live in a much more data-enabled world today, where I will have business analysts and data scientists and marketing and product analytics and research, all which have, right, legitimate needs to access, store, and process data, perhaps in completely different ways with completely different tools. And so there's not a one-size-fits-all platform, right, that's going to solve all of these needs. I can't put everything on a transactional SQL server, right, and think that all of these different users are going to get what they need out of that type of platform. So instead, I want to be able to bring multiple types of processing frameworks to bear so that each of those use cases can process data in the way that makes the most sense for both their use case and for the users themselves, while coming to, right, this common data store that they all can read from. So I may have things like Apache Spark and Databricks and Hadoop, where we're talking about how we process things parallel, right? How we scale out. And in this case, we're talking about data parallel processing. This is batch processing where I have huge sets of data and I want to be able to spin up one or more workers to work across that data. So think kind of one big question, lots of hands working on the problem, right? These are tools that are going to let people solve problems or ask questions over these ever-growing sets of data, right, that we have as we store all this semi-structured and unstructured data. We also have task parallel platforms. This is really important as we talk about streaming processing or micro-batch or real time. This is, think, low latency processing, where it's not one big problem with lots of workers. It's a relatively small problem, but I need to be able to do it with massive amounts of concurrency. So if I have a huge network of IoT sensors, right, and I need to be able to evaluate and decision on small changes in sensor data in real time, right? I don't want to wait and aggregate that all together and then try to analyze it, right? I need to make that decision tens of thousands of times as the data comes in, right? And that's where we may have things like Apache Storm and Kafka and Samza and some of these other task parallel platforms. And what's great is with these ecosystems, with this shared storage platform, we can bring these different processing frameworks to bear without having to build completely siloed separate systems. So this is an overview of the Microsoft Fabric landscape. And what you'll notice here is as the different use cases, right, are spelled out, they really begin to group into different solution sets. And so different tools, be it Data Explorer or Power BI or Azure Synapse, right, can be brought to bear to help solve sets of problems. But underneath it all, we still have this shared, distributed, interoperable data layer so that I'm not having to implement each of these in separate silos. I can build a data ecosystem that supports all of them together. And that's what makes it a modern data approach. With that, this means that people can begin to use the best tool for their use case rather than the best tool for how the engineers needed to store the data, right? So whether or not this is Snowflake allowing you to use both SQL and Python, right? Using a notebook style, data science driven approach, right? Or traditional data pipelining tools, whether or not it's Synapse having runtimes for both data engineering and Spark notebooks, or SQL queries and typical data warehousing. It allows me to bring the right tool to bear against the data without making completely separate copies or structures of that data. We also have to be able to maintain that data. We have to be able to control that data and control who can access and use it, right? When everything was in one system, that was already a pretty hairy problem. But if we start talking about truly shared interoperable data stores, where people can begin to bring many different types of data processing engines on top of that data, right? And we're democratizing that access. Governance in these modern platforms becomes more and more important, right? With that, you'll see most of these platforms begin to build in continually maturing tool sets, be that the Horizon catalog in Snowflake that helps you define both how my data is going to be modeled, as well as the interoperability in the Iceberg layer, data discovery and privacy, compliance and data categorization. We have Purview in Microsoft Fabric, right, which does many of the same things, as well as capacity monitoring and metrics, metadata scanning, automatic management of your OneLake data hubs. These tool sets begin to let us say, right, I can store the data, I can expose or share the data, I can create rules over how data can be used without having to necessarily control every endpoint where the data is used. And so this managing of your data estate, right, your both data storage and the multitude of processing options becomes really important as we talk about these modern platforms. Luckily, we've got a talk on that as well. Preston Asarvi will be talking about specifically how you use this to help ensure data quality and make sure that across all these use cases, you're providing data that each of those users can trust, use, and take action on. So that's coming up on November 6th, if you'd like to register. And then lastly, you can't talk about data in 2024 without talking about AI and ML, right? It is certainly the buzz for every aspect of technology right now. But key to any AI and ML uses are both how you manage the data that you're going to build these models on, but also how you manage the processes. And so as we look into AI or ML, it is these modern data frameworks where we are going to have our pipelines and our processes for training data sets, for building augmented generation of models and fine tuning, right? This is a Snowflake on the left side and Databricks MLflow on the right side of the screen, right? We've got to begin to build out these operational models and these pipelines for how we build, train, and refine all our AI and ML models, just like we've traditionally had our data pipelines for data warehouses and reporting data marts. And so these are coming core parts of these modern data platforms and modern data ecosystems. So they are a key piece to look at because it's one thing to say, my platform is AI enabled. You can use Copilot or you can use OpenAI and you can ask questions about it. right? It's another to say, my platform can help you build new AI and ML solutions. And that's really where our modern data frameworks have to come to bear, right? These are more examples of Snowflake ML and ML Flow, some of the different, right? Not just components that are required to have true modern, mature AI and ML operations, but some of the different roles, right? What's the role of the data engineer versus the scientist and the ML engineer? How does the business interact with these models? These are places where, again, this idea that we can begin to bring and piece together the right tools rather than having a one-size-fits-all solution really makes these modern platforms a huge part of the solution. As we mentioned earlier, we do have some AI talks coming up. So just a reminder on that again, if you want to dive more into how the modern data platforms help unlock and help you leverage and build your own ML and AI solutions, highly recommend you listen to these talks coming up. So if those are the characteristics of a modern data platform, is the value we get out of it more from the platform or from how we use the platform? Well, I would define now, to think back to kind of the very beginning of this presentation, what is a modern data platform? As a modern data platform is a whole ecosystem, right? And that ecosystem is going to have to give me ways to work with traditional data. That doesn't go away, but add on top of it the ability to work with semi-structured data in a highly scalable manner, to bring more tools and interoperability, and to bring the right kind of compute for a use case to the data rather than coupling them together and making me build out multiple siloed solutions for all my different stakeholders. So if we define that as the modern data ecosystem, right, we can talk through a number of examples where that platform, right, really is truly an ecosystem of tools. If we talk about Microsoft Fabric, right, there's a number of tools that have been built up over the last number of years on the Azure platform that have finally come together to build a comprehensive platform with Microsoft Fabric, right, covering storage, acquisition, warehousing, analytics, self-service, monitoring, right? This lake-centric and open platform, right, really is an ecosystem of lots of different tools to help you solve the different modern data problems. Similarly, right, if we talk about Snowflake, they are a data architecture that built for the cloud, right? That used to be their tagline, where they took their proprietary data storage, right, and built different types of multi-cluster compute and cloud services on top of it, right, to provide that data ecosystem or platform. And to give you an idea how fast this is moving, this is a slide from last year, right? I think I used this slide in a presentation about this time in 2023, right? And this was a representation of how Snowflake was showing their platform, right? They've had to grow that since then, right? Because not only do they continue to grow as a platform, but with interoperability and this idea of bring use cases to the data, right? The number of things you can do on the platform continues to grow as fast as the industry, right, can grow. But what's great here is if I was using Snowflake 2 years ago, this isn't, well, let's move to a whole new version of the platform and migrate all our data and do something completely different. Because we have this model of bringing the right compute to the data, and we're treating it as an ecosystem rather than a closed platform, right? As they continue to add all these capabilities and use cases and Cortex AI services and Horizon for data governance, right? You're able to continue to use that platform and simply unlock more and more ways to leverage that data, right? And again, right, it's an ecosystem. So they may have a large number of things they've built internally, but because everything's interoperable, or interoperability is such a key aspect of what encapsulates modern data, right? The number of partner platforms and partner tools, right, continues to grow as well. And in many, many cases, these aren't tools where you pick one and that defines everything about your data solution. Again, it's you can pick the right tool for the right use case. And if that doesn't work for something else, you don't have that sunk cost where you have to start over. Right? With a modern data platform, you can continue to evolve and leverage the entirety of the ecosystem on that kind of core fundamental base of storage and compute. Right? I've mentioned AWS, I've mentioned Fabric, I've mentioned Snowflake a lot, just to show you they kind of all work the same, right? AWS, we've got Redshift, but that's not a single solution either, right? If I were to implement Redshift and do a large implementation, right, I'm going to bring lots of different tools. There's a whole ecosystem of AWS solutions, right? Many of which match up with a lot of the same solutions we talked about in the other platforms, and which share interoperability, again, with a number of the other platforms. So it's truly not a one-size-fits-all approach where the platform picks what we do, but instead these capabilities are enabled by the platforms. So that
Before we
probably
move on,
yeah, go ahead.
another question. What's the staff overhead on managing a modern data platform? Do organizations have to hire a whole staff of data analysts, data engineers, and data scientists just to get started in modern data?
That's a great question. And the answer is, in truest of consulting style, it depends. But what it depends on is how you want to approach it, right? If the answer is, I want to have just a simple data platform stood up with semi-structured data in it, and I want to be able to query it, I can use these platform as a service providers out there like Snowflake, and you can have a solution up just as quickly as you could with a traditional database. So if you can think of what it would have taken someone to stand up a SQL Server or even a Microsoft Access database, right? I can stand something up in Snowflake with the same amount of effort. I don't necessarily need, full-time administrative help that's continuing to manage that platform, right? Unless my use case and my business criticality justify it, right, or need it. Now, there are other solutions that will bring the same type of capabilities to bear, but may require a lot more on your staff, right? For instance, I could use a cloud-based Databricks platform, or I could run Databricks in my own containers in a Kubernetes cluster that my platform engineers built up and have a Terraform system that manages that they've written as fully infrastructure as a code. That's a great answer for a large enterprise. That's a great answer for a very mature organization that wants very fine-grained control and wants to be truly cloud independent. That's probably not a great answer if this is going to be your first step into creating a modern data footprint, right? You probably do want to pick platform as a service. You don't want to spend all of your efforts in simply setting up and maintaining a platform. You probably want to focus more on what you're doing on the platform. So it's not one size fits all, and there's not a single answer. You can absolutely have a massive infrastructure need from your staff to manage a modern data platform. If that's how you've chosen to put it together, and those are the components you've picked. But there's a lot of variety and option out there. And between Snowflake and Fabric and some of these platform as a service options, there really are some pretty low effort ways to get a modern data footprint in place and begin to allow different users in your business to access data with their own tools without having to have that kind of dedicated full-time internal IT support. To that, though, a lot of what matters becomes not just the platform, because as we just mentioned, the platforms kind of all are truly ecosystems, right? They bring lots of these things to the table, but instead it's going to be how you use them. Because I can have a modern data platform and still treat it like a mainframe from 50 years ago and not get a whole lot more out of it. So some of the core changes in the way we approach modern data platforms and how we are leveraging its functionality are probably just as key as what the platforms bring to the table. So we used to focus on ETL. Let's take the data, transform it into what we think the business is going to want, right? And store it in that very rigidly defined data warehousing model, right? We put a ton of work up front in defining how we were going to store it, right? Transforming the data, and then we'd store it. That worked great if we made all of the right decisions, right? And if we had all of the foresight into what and how the business was going to ask questions. What's not great about it is if I've taken my data, I've prepared it like the carrots here, and then I find out I need it to be used in a different way, right? In the old system, you kind of had to go back and rebuild your whole process, right? That was that very kind of siloed, one-size-fits-all approach. With the modern solution, right, we're going to store the data as early in the process as we can. And then we're going to define what parts of it we want to process based on how we want to be able to use it. And we want to allow that use to be defined more by what wants to consume the data than what's acquiring the data, right? It gives us a lot more flexibility, right? In this case, if I don't shred my carrots into little tiny strips when I first buy them, right? I've got a lot more options when I go to cook and how I can use those carrots, right? Very similar with data. We don't want to make decisions early because we don't know what all of the future questions are going to be. So we want to store data in very reusable, accessible, defined ways, but so that each of our users can still bring those different tool sets to the case, and we've not pre-processed, right, or defined the questions that they can ask of the data. Right, and you don't have to use a carrot analogy, right? There are plenty of more technical diagrams that can show you the same thing. We also need to start treating data more like we treat software. And that is as a process where we can continually build, promote, test, and release changes to our data platform, right? If anyone's used a data warehouse from the early 2000s, right, they took months or years to build. And if you needed to change anything, it was an absolutely mammoth undertaking. Not only did you have to get all of the data engineers and architects and data modelers to figure out how to make those changes to the model and implement them, they had to coordinate with every part of the business that made any use of the data warehouse downstream and make sure that they all made changes in coordination and launched at the same time. It is not an exaggeration that I had a client at one point where we needed to add 2 elements, 2 pieces of data to an existing data feed. And the answer was that that could fit on their roadmap in about 2.5 years, right? That is not an agile process. That is not a process that can be responsive to changes in the market, changes in technology or business needs. Luckily, with modern platforms, we have the ability to use different tooling that lets us treat data pipelines and data engineering as much more traditional software projects. That means we can not only use things that can be modularized in ways that we couldn't before, using Python and JavaScript and SQL in new ways. The platforms can help us manage dependencies, manage execution in parallel, but also feed into fully mature source control, continual release, and testing processes. That's true with a tool like dbt, which works across platforms. That's true with a lot of the tools in these platforms themselves, right? If we look at Fabric, between data flows generation 2, their data engineering tooling for Lakehouse with notebooks, their more orchestration-driven data pipelining tools, right? I have the ability to have software releases of data pipelines and data platforms. And that allows for as much of the flexibility of modern data, right, as anything else. Because the fact that I can bring 2 new tools to bear in a very quick amount of time only matters if my processes, right, are robust enough and agile enough to continue to adapt for that. Because of that, we also need to bring some life cycles to bear in how we think about our data projects and data problems. These are 3 examples here: the big data analytics lifecycle, CRISP, information product canvas to treat data like a traditional IT product, where we can begin to change the way we think about managing our data projects internally so that we can be more reactive, right? And we can leverage the flexibility of these tool sets rather than have these great ecosystems that will bring new things to bear, but our organizations can't move fast enough to leverage them. So if the business needs insights, these tools may let us get there, but we've got to make sure we've got processes in place, right, that will let us move fast enough. Data enablement is one of the ways we here at Improving like to talk through this with a lot of our customers, right? And that is a way we talk about how the consumers of data, right, can work with engineers to build, right, a process where both are stakeholders and can have both rapid discovery and development and engineering without losing the maturity of the process, making sure we're still staying true to data curation and quality and governance while getting business solutions out, right, more quickly. So kind of in conclusion, if we came into this saying, what is a modern data platform? What makes it modern? What makes it something that isn't just, right, a new way to pay for a data product that adds more complexity, but solves the same old problems, right? And the answer is, right, if we think about the competing problems we have to solve in the data space today, moving away from those kind of siloed, all-in-one data stacks of the past and into a modern system, right, which is an ecosystem of solutions that we can bring around kind of core shared interoperable data storage, really is the fundamental change of a modern data ecosystem. So as you build anything today, right, the question's probably not, am I building today exactly what I want my system to look like in 5 years? You're probably going to be wrong. The answer to the question that you need to ask is, do these tools let me build something today so that as my vision changes for what my system should look like in 5 years, I can continue to build on top of it and leverage what I'm building today without it going to waste, right? And that's truly what I would define as what we can approach as a modern data platform versus a legacy data platform, is that ability to use it as a stepping stone and to continue to evolve the platform without losing the investments you make in it today. So if there's any questions that are left that we didn't answer or we didn't answer well, please put them in chat and Bud will make sure we ask them here. You can connect with me on LinkedIn. You can connect with Improving. However you want to ask us questions, we're more than happy to answer or have conversations about this. And then this webinar series, right, is going on. It's a 12-part series, so we are still early. Please visit our website, improving.com. Go to Thoughts Webinars. You can see recordings of any of the ones you've missed. You can register for all the upcoming ones. I'm sure Bud will tell us exactly what's upcoming here in a second. But I hope this was helpful. And I hope it's gotten everyone thinking about what makes a modern data platform different and how you can use it to begin to leverage data more in your business.
Yes. Getting that last note in for where to register for future talks. Coming up next in the technology, today's technology tomorrow, tomorrow's technology today, the triple T is Scott Poulin. And he's going to talk about AI-powered enterprise transformation, AI roadmaps, and high-value use cases. Because one thing that a lot of people don't talk about in AI is return on investment. I'm sure Scott's going to cover that. Also, thank you everyone for attending. I hope you all have a great day and hope to see many of you next week and tomorrow.